Welcome back, everybody. Here we go. And we had
Dr.
hello.
On the test outline for the same question we were solving, you mentioned there's no Newman projections or no Fisher projections.
Correct.
So what does that mean? I know.
Stop studying Newman projections and Fisher projections.
No, actually, I didn't get to that point.
Yeah, don't do that. Yeah, I forgot. Well, I didn't forget. I picked a practice test that didn't have them and used that as the outline, and you caught a break. We will be doing Fisher projections after when we continue our discussion of chapter 3, but that will be for your next test. Okay?
Sounds good.
All right.
Okay.
Now on this one, we're going to do the boiling point. Your test will have 5 molecules, not 7. And the point counts go down. I believe it goes down to 2 and 4. Whatever the outline says is the point count. And we need to figure out, here's how I figure this out or start. I look for any molecule that participates in hydrogen bonding first. And remember, we have them in order in our notes. It was, I think, the last page of one of our last days. Carboxylic acids had the highest intermolecular forces, and then alcohols were a close second, and then a little bit down were amines that had hydrogens, so primary and secondary only. So do we see any of those here? And the answer is yes. We have here. And on the test, we're supposed to explain. So remember, this won't be on your page. So you'd start like this. And notice I got rid of the box where you're supposed to have less than 1, less than 2, whatever. It won't be there either. It looks like this, your test. 5 molecules instead of 7. Feel free to use these Roman numerals. You don't need to redraw any of these molecules. And it says from lowest BP first, that means highest BP last. And you can do your explanation like this. I'm not going to grade if you're doing complete sentences. I will leave that to the good people in the English department like Miss Hasakanavala, and they will grade your English at other times. And you could write over here, and you could say this has hydrogen bonding. Now later on, you're going to have another one with hydrogen bonding, and you're going to have to compare. So you should say strongest hydrogen bonding here. And the reason is an alcohol's hydrogen bonding is stronger than an amine, even an amine with 2 H's, because the O is much more electronegative than the H, and the N is less electronegative than the O, so that it's not as polar a bond. So you've got your 3, your H bonding is here, you got that guy covered, and this guy, and you should put him right over here. And say it has H, at least acknowledge it has H bonding. After you write hydrogen bonding the first time, you should go HB, so you never have to write those 2 words again. If you come up with HB randomly on a test, I have no idea. Hubert Boyles, is that what HB stands for? I don't know. You better tell me what it stands for. And you'll say HB here, because you've already explained what HB stands for. And it's understood it's not as strong because you didn't put it at the end. So there's your hydrogen bonders. Next up, you want to go for dipole-dipole. And we're looking for anything with our carbonyls in them, okay? Carbonyls are polar covalent bonds. So I want aldehydes, ketones, esters, tertiary amides. Are those all of them? I think so. Yes. We have a carboxylic ester here. So let's go with a new guy right here. And I don't think anything else is a carbonyl here. This is an ether. If you're uncertain here, this is a hexyl group over here. It's got 6 in a row. and there's two of them. So there's hexyl left and hexyl right. That's an ether. Please, just ethers are almost the same polarity as alkanes. Please do not tell me they're polar. And I had this thing with a ester, and you need to tell me VI. Not as good as those, but it definitely has dipole. It's the only one, so I don't think I need a short form. That's a weaker intermolecular force. That's why you put it to the left of these two. I think everything else is London only. Some of you are zooming in on this amine and say, wait, that's polar. That is not a polar amine. There's no H's on the end, so there's no hydrogen bonding. And when you have 3 carbon groups attached, and let me outline the 3 carbon groups, 2 methyls, and the 3rd carbon group is this chain. Okay, that thing is nonpolar. Let's count up how many heavy atoms it has. What do I mean by heavy atoms? Atoms, not hydrogen. Heavy atoms. HA, let's do it in, I don't know, I haven't used black yet. HA equals heavy atoms. I'm determining London first based on the number of heavy atoms. The bigger the molecule, the more the London forces. Let's do a quick count, shall we? Carbons count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And 11. HAs, can we do heavy atoms here and here? HA, and we have 11. And the bottom one is also 11. No, it's not. I miscounted. 6 times 2 is 12, plus the heavy oxygen's 13. I was only looking at the CH2s. We have a winner for those two. If I can make it look like a 3. That's close enough. 13 heavy atoms is going to have more London forces than 11. Notice I didn't use the B word. I won't even talk about the B word until I need it. You say, what's he talking about? It'll come up. We have another 11 over here. And the very first molecule, there's 3 of these. That's 6, 7, 8, 9, 10, 11, 12, 13. I need both the 11s before the 13s. And the 11 Roman numeral II is going to be superior to V. And this is one of those times I'm going to use the B word, but only when we have the same number of heavy atoms and the same polarity. These are both London only. So please acknowledge that first. London only. That's why they're on the left of my answer. And can I go LO in case I have to use that again? And 2 has no branching. Remember, when there's no branching, molecules can get closer to each other. Closer to each other increases the London forces. Now we're comparing the 2 13 heavy atom species, 1 versus 7. 1 versus 7. It's got a branched methyl here. We can even use that thing we did at nomenclature just to see what kind of branching we have here. There's 3 of those. Sound effects optional. This is not branching here. This is just a chain, but that's a branch with a branch on it. Maybe you want to do this. I don't know. Cross it off. N with 2 methyls. And then that's really the only branch on that one. And that was an 11. Have we did 11s already? What did I do wrong? 11. V versus 2. We already talked about that. I was supposed to be down here, wasn't I? Please agree with me. There's no branching here. 6 carbons in a row, then an oxygen, then 6 carbons in a row. No branching on Roman numeral 7. That's going to put it over here. Let's use another color. Oh, I'm having trouble with my Roman numerals, aren't I? Just copy them. That's a 13, and the other 13 was 1. And 1's definitely got 3 branches on it. It's got a methyl and 2 ethyls. So you say these 2 are LO, and you comma, and which one has the branch? The 1. 1 has branching, so the other one has no branching. Well, we can reverse our logic here. 1 is branched more. Branched more. And that is sufficient for this whole question. Save that. And it looks probably a little different than the answer key, but this would be full credit. The answer key would be full credit. And pick whichever way is more comfortable for your explaining abilities. And then we had requests. It was a pretty vague request to do a whole section of an exam. So let's look at winter 20, which I didn't get to this part, I guess. Winter 20, I'll bring it over here and maybe we can decide together which parts we like the best. Sadly, I think I closed it. Give me a sec. I'm in the test 1 area, winter 20 right near the end. This semester, we try to not talk about too much. There it is. And I'll slide it over to this screen in a second when it opens. Okay, is it gonna open? Enter my password. Are you kidding me? This is Adobe. It's already open. Okay. You guys getting Adobe password requests lately? I don't even, that's weird. What section was that? 3, nomenclature. Is there anything from here that you think we haven't already addressed? Feel free to interrupt here. I did hint that big crazy thing that you had would look more like this one. So maybe you want to look at this one. Remember that nomenclature we did with the tetrahedron in the middle and the chains? I numbered one backwards. The students corrected me. This is closer to what you will see on your test. So let's steal that one. Where's my snipperdoodle? And here it comes. I just need this. You won't have boxes on your part 3. It'll just have molecules and it'll say, name this. Minimize. Nice. Oh, gotta be here to do that. Okay, so what was our enemy in this question? Enemy was the branches. And how do you fix that? Let's see. I'm gonna get rid of this 2. There's 2 ethyls on the end, and now it's down to 1. Please put on the one you erased. And there's a methyl in the middle. Put it where it belongs. This is a chain. Anytime you have CH2s, parentheses, just chain. We can count inside the parentheses. There's 3 methyls here. Not really. That's misleading, isn't it? One of them is the chain. The other 2 are methyls. And now I learned my lesson from the student who correctly pointed out we should go from here because that puts a group on 2. If you went from here, you don't get a group until 3. 1, 2, 3. No, rules of nomenclature. Lowest number for first group. So I decided with the methyl, the first methyl, compared to this ethyl. I didn't even get to the second methyl because I already broke the tie. And use your fingers. I need to go from 3 to 6. Put your fingers up and count from 3 to 6 with your fingers. I need 4, 3, 4, 5, 6. And then 7 is here. 8, 9, 10, 11. Undecane. And this molecule has 3 methyls and an ethyl. Yours might be like one step above this with maybe one more type of group on it. But yours is closer to this one than the crazy tetrahedron. And let's see, what do we got? On carbon 2, and there's methyls, 2 of them, and 7, a methyl. That's 3 methyls. And methyl is after, this is ethyl. So my usual way to avoid gaps in my answers to put the last group first. 2, 2, 7, trimethyl. And an ethyl on 9. Okay. Let's go this way. We haven't done a single combustion question yet. Can I just pick one from Winter 20 because it's open? And we'll pick the harder one. If we can do the harder one, we certainly can do the easier one. And you have 2 of them on your test. Oh, I went to the wrong spot. This one here, and combustion's always right there. I'm going to steal the second one. Yours won't be a box. What am I going to do? I'll just copy the heading. And here it comes. You'll have that exact sentence. And we'll put it down here. This is Winter 20, Part 4. Nope. Hey, sorry, talking to my computer. Stray dots here. And then I'll grab the actual reaction. It's the name of the molecule. And I'm here. And I got so much stuff open, it's crazy. And we'll do this one. No, I just need the name. You won't have a box. Okay. So please do not draw the molecule. You have enough information in the name to get the formula, and it's the formula you need for combustion. And then we have to figure out what to do with rings. Because there's only one formula I memorized, and that was for molecules without rings and without pi bonds. No rings, comma, no pi. If your number of carbons is n, it looks like an M, n, then the number of hydrogens is 2n plus 2. Please don't memorize any more formulas. Just memorize this fact. Every ring, what do? Lose 2 H's so you can tie the ring together. Later, what are you going to do for every pi? We don't know pi's on your test. Same story. Lose 2 H's. All right, do rings later. We have 5 C's in a cyclopentyl. Isopropyl, as the name says, 3 C's. Heptadecane. 17 C's. Did I miss any groups? I don't think so. 25. So C25, what's 25 times 2 is 50 plus 2 is 52. This is not the right formula. It's where we start. We have a ring here. One ring. Bicyclo. Take a wild guess. How many rings? 2 rings. Minus 6 H's. Why? Every ring lose 2 H's. Your correct fuel formula, C25, H, 52 minus 6, no calculators. Yes, I trust that even though some of you will have a phone right in front of you, you will not be using it. Your honor is on guard here. So 52 minus 6 is 46. And what are you reacting it with? Oxygen. You got to know that. I'm not going to tell you that. What are you producing? You have to know the two products always. CO2 and water. And there you go. So right now, 2 out of 4 points. I think I made them 5 points on your test. No big deal. These are not hard points, so I don't think you'd be upset if I changed it by 1. What do you balance first? This is Chem241. You can balance carbon because it appears only here 1 time and here 1 time. You can balance hydrogen first. It appears here 1 time and here 1 time. Please do not choose oxygen to start. It appears here once, but here twice. And I'll do it the long way, and then I'll show you a shortcut and when you should use the shortcut. The long way, before I proceed though, I'm going to copy this. All right. The long way is to say carbons are a nice way to start. 25 carbons here. You can only add numbers in front here. So you're going to put up 25 in front of CO2 because each CO2 has 1 carbon. And then the hydrogens, 46 here. How do you get 46 out of here? You put a 13. Half of 46 is 23. Okay. And having done this for 30 years, I know that this is going to be one of the ones where I have to multiply everything by 2, but I don't know that yet because I'm pretending I haven't done it for 30 years. Add up your oxygens on the right side. We have 50. This is the oxygen count, okay? You don't have to write the word oxygen. I'm only going to grade your answer, okay? Each CO2 has 2 O's. Each water has 1. And now you've got to put a number in front of O2 that multiplies by 2 to give 83. 41 and a half.
Sorry, is it 73?
Uh-oh. Probably. Yes. Thanks for catching that. I don't know, 83. I think I added the 3 to the 5, didn't I? All right. Still going to have the same half issue, though. 73. Yes, that was the perfect time to point that out because I wrote the wrong answer already. What's half of 73? Okay. Now, hey, a sense of numbers is an important skill. Doing division by 2, I know you'd rather use your calculator. But, you know, what's half of 73? Well, why don't you do half of 72 to get a ballpark? Isn't that 36? Well, you know you're above 36 because 73 is bigger than 72. So 36 gets you to 72. Then another number to multiply by 2 to get you 1 is 0.5. So just go to the number below that to get the in front of the decimal and a half. It's always going to be a half for combustion if you have to do this. All right, and now you say, I'm done, I'm going to move on. Well, if you think you're done and it's a 5-point question, I'm going to give you 4.5 out of 5. Because as an organic chemist, I have no objection to what you did. But I don't want to be shunned by my physical chemist friends, and I have a few, and my analytical chemist friends, I have a few of those. And they say, you can't read this reaction as one molecule reacting with 36.5 molecules because 36.5 molecules doesn't exist. So they want you to multiply everything by 2. So that's why I copied that thing. I want to get my 5 out of 5, multiply everything by 2. You're going to be putting a 2 here. And go with the purple. 36.5 times 2 is our 73. Oh, some people prefer writing 73 over 2 here. You would have got the same score and not have to do the divide by 2. Ah, you could have done that. Put this here. I have no objection, but you're still going to lose a half point. You got a fraction. And 25 times 2 is 50. And 23 times 2 is 46, and you're done. And the easier way. The only time you're going to have an odd number of oxygens is if you put an odd number here. If odd, start off with the times 2. Okay? So right away, I take my fuel, multiply by 2, and then balance right from there. How many carbons you got? 50. How many oxygens? 73. You got, well, no, don't do oxygen. You do hydrogen next. 46. Look, 46 times 2 is the same as 46 times 2. 46 times 2. It's 46. I got the answer right above, and that's my problem. I'm looking at it. And then you're going to add up all your O's. You're going to have 100 plus 46. And there's your 73. And it gets you there a little faster. And only if this is odd are you going to do the times 2 right from the beginning. That's it. If that was even, you wouldn't have any problems. And I hope that helped. And then where are we going next? This one's up to you. Hey, you guys are now in charge. After the break, if you have, you're going to chime in with requests. I need these 3 pieces of information. What semester? What part of the exam? 1, 2, 3, 4, and what question number? And I'll come back and we'll go on a first come, first serve basis. You guys can even discuss amongst yourselves while I'm gone. So I'll see you very soon.